While the chemical definitions of acids and bases are really important to know as far as what reactions are occurring and sort of the under the hood elements of acidity, what may come up even more in healthcare is the pH scale. And this is a nice number scale that helps us understand how acidic or how basic a solution might be. And when we're looking at this scale, it goes from 0 to 14. It can actually go beyond this scale, but that's very uncommon. It's not strictly defined as 0 to 14, but that's where you'll find things mostly. And 7 is neutral. And remember that what we said is that H plus is our unit of acidity, OH minus is our unit of basicity, and that they're both always around in a solution at the same time, to a small extent. And if they're equal to each other, we say that solution is neutral. There's some H plus, there's some OH minus, but for each one there is, they kind of cancel each other out. That's neutral. We associate that with water, pH equals 7. If there should be more H plus, well, remember H plus is associated with acidity. More H plus means that it's an acidic mixture, and that pH would be less than 7. An acidic solution, I should say. And if the pH is greater than 7, well, that means there's less H plus than OH minus. It's a basic solution or alkaline. And this word alkaline we should associate with high pH or higher than it should be pH, and acidic with lower pH or lower than something should be pH. Too acidic means more H plus than there should be. And this is the number that you're generally going to use to measure acidity and basicity. It tells you what the environment of that solution should be. Does it have more H plus or more OH minus in this aqueous solution? And if we look at a variety of substances, we can classify these as acidic or basic. So the ones that are on the acidic scale, battery acid all the way over there, very, very acidic. Stomach acid, lemon juice, starting to get a little bit less acidic. Well, these have a quality to them that we know, right? They kind of taste sour in the case of lemon juice and vinegar, and when you get really extreme like battery acid, they end up being corrosive and things like that, right? They have different properties. As we move up towards neutral, that's pure water, and then towards the basic scale we have blood, which is just slightly basic, probably not all the way to 8, and then, hand soap, laundry detergent, and then we start to get to stronger bases like ammonia, liquid bleach, and then sodium hydroxide, lye, other concentrated alkaline solutions. And here, right, sodium hydroxide, it's a powder. What's really going to determine how basic it is the strength of that solution. But if you have even a reasonable amount of sodium hydroxide, that'll make a quite basic solution. Blood pH, again, not quite 8 as on the previous chart, but around 7.35 to 7.45. And this is a really important pH to know, and something that you should commit to memory is that blood pH likes to be just a little bit basic, right? Around 7.4. I think that's a good number to remember. We'll do some investigations of what happens or how do we describe blood pH that's different from this. But even a small change can be dangerous. The pH really dictates the chemical environment for things, and blood is no exception. Blood is required to do a huge number of biochemical tasks, and it needs to be kept at a certain pH. We're going to be looking at how it maintains this pH in the coming videos, but note that even a small change can be dangerous, down to 7.25, acidemia, 7.55, alkalemia, and note that acid acidic is too low, and alkaline alkalemia is pH too high. We need to stay within the normal blood pH range. We'll look at how blood does this in the coming videos.